So now I want to briefly talk about the last homework problem and give some hint for solving this problem. So this is space speeding fine. So what I talk about won't make too much sense until after you read the problem. So you probably want to watch this video after you started working on this problem and started thinking about it. So this is a simulation problem. So you are simulating movement and try to compute some quantity during the simulation. Simulation problem can be, I find they are fairly tricky to write, and it's very bug prone. So usually it's, at least when I write it down, they tend to have bugs, and I have to debug to figure out what went wrong. However, my main observation is the way to make simulation problem a little bit easier is to turn it into discrete events. So essentially, you want to model simulation as a sequence of events happening, and then you just take each event and then do something for each of them, and you can sort this event, and then you just take them, and then so there's the separating the logic of a generating event and the processing event. So that generally helps simplify the logic. And in fact, in some cases, you will, when you process event, this will generate additional new event which need to be added. So in that case, you will need to use data structure that can dynamically sort things. So you can add things while at the same time maintain sorted. So this can be done using either a priority queue or a ordered set. So in the next topic, topic 10, we're going to talk about the ordered set, so which can achieve this functionality. But for this problem, we don't have dynamically new event. All the events are already given in the beginning. So what we can do is we can generate those events and then sort them and then just process them one by one. So more specifically, you need there are two separate kind of events here. The first kind are the segments, which describe the speed limit. So I would recommend creating a vector of a segment. So each segment contains a starting position, ending position, and speed limit. So you can use this pair type recursively by creating pair of two long for the positions, and then speed limit, the integer is enough. And you also need to create a vector of speed change events. And this should be based on position, because that's what you're going to need to correlate these two events. So you want to know in this segment what is the traveling speed. So you need to know at what position speed changes. So the input gives you the speed changes based on time. So you need to put that the time-based speed change event into a vector, sorted, and then go through it. You can generate this speed change event based on positions. Once you have these two vector of events sorted, then you just need to scan through both of them to figure out the total fine. So I find it conceptually easier to think about for each segment how much fine is accumulated. So you need to figure out what is the speed that that is traveled during this interval. So you need to look at the speed change event and see whether it falls inside here or after this segment, and then figure out the actual speed in this segment. So in each segment, there might be speed change event in the middle, or there may be more than one in the middle, or there may be zero. So your code should be able to handle all of that. So the complexity should be linear after you sort them. So sorting is n log n, but after it's sorted, the complexity should be linear. Okay, so a few of the homework problem are this a little bit like a simulation nature. So you go through things and then you try to keep track of information. So being able to do that well, I think it's a very important skill, and it's something that's in general not taught because it's not a data structure. It's really sort of just programming, but oftentimes students don't have chance to practice those kind of simulation problem in a normal in a standard CS curriculum. So I expect this to be hard. But I think going through the process and debugging it, that should help you writing a lot of programs in the future. All right, so that's the end of this topic, and we just have one more topic to go. In topic 10, I plan to talk about set and map.